What I think is amazing about the translation pipeline is that it always works. If you have a correct tail recursive algorithm, you will always generate a correct loop from the translation pipeline. So even if you have no idea how the tail recursive method works, as long as it's correct, you'll always get a correct loop. Now, some of the things that people often run into with loops are things like off by one errors and things to that effect. And we'll talk about that once we get to these things called for loops, but in general, translation from a tail recursive algorithm will ensure that you write correct code. So, one of the slightly harder tail recursive algorithms that we talked about is this Fibonacci program. So, it's a method that produces the nth Fibonacci number using tail recursion. So, we're going to translate that into a loop using the translation pipeline. Now, this one throws a few wrenches into our system because of multiple base cases and multiple accumulators, but we'll get to those. So, first thing we did, I went ahead and did this for you, is we write the header. Okay, it takes in the same parameters as the standard recursive solution and the tail recursive solution. Okay, that makes it very easy to test. Okay, now we're going to create two variables, int a and int b. So again, we can just copy those, set them equal to the default values that we pass in the driver. Int a equals 0, int b equals 1. Now, we have a while loop. So what are we going to put here? Well, with the factorial example, we said while it is not the case that the base case is true. Okay? But there's something amiss about this because there are two base cases. So we want to continue looping as long as both of these are not true. Or rather, we want to continue looping until one of these is true. Okay? So how do we do that? Well, this is also a mechanical decision. Okay? So we're going to put a not, and then we're going to put some parentheses. Then we're going to copy this condition. Then we're going to put some ors here. And then we're going to put the other base case condition. Okay? So this says while it is not the case that n is equal to 0 or n is equal to 1. Okay? So while n is not equal to 0 and n is not equal to 1, do something inside of here. So remember how De Morgan's law works. If we, let's create a new window. If we have a not, and then we have n is equal to 0 or n is equal to 1, then how will this work? We will distribute the negation inward. So this becomes n is not equal to 0, n is not equal to 1, and then we flip the or to an and. Okay? So while n's not 0 and n's not 1, do whatever is true in the loop. Okay? So now what do? Well, all we have to do is just create these variable update statements. Okay? So we have three variables here. All of them are being updated. So n is becoming n minus 1, a is becoming b, b is becoming a plus b. Okay? So let's just write that. So n is equal to n minus 1, a is equal to b, b is equal to a plus b. Okay? And then we have the atomic return values. But remember that in order to get out of this loop, one of these conditions will be true. We don't know which one of them will be true, so we need to check for both. So we'll say if, let's see, n's equal to 0, return a. Now we could do an else if and say n's equal to 1, return b. Otherwise do something else. But the problem is that there's nothing else to do. We only have one of these two cases, either n's equal to 0 or n's equal to 1. So what we can do is just get rid of that and collapse it into an else statement. So remember, in order to get out of this loop, one of these two must be true. N must be equal to 0, or N must be equal to 1. Okay? So, we're done now, right? Let's run this code and see if it works. But if you know me by now, you'll know that something isn't quite right. So, multiple of these tests fail. In fact, I think all of them fail. Not all of them, just 5 of them. So, there's an issue here. The issue is that we didn't follow the rule of update, right? Remember, if you have, in the recursive call, if you see that one parameter uses another parameter, then we have to update it before we update the other. Okay? So, is N using either A or B? No, it's not. So, N is fine. A is using B, but B is using A plus B. So, the problem here is that we have this cyclic relationship. A relies on B, and B relies on A. So this isn't good. Well, what do? The solution is what I call the rule of temporary. It's actually very straightforward. All we have to do is store one of the variables in a temporary variable. So let's say we'll choose A. Okay? So we'll take A, and we'll assign it to be equal to TA. Now wherever we use A later, we're going to use TA instead. Okay? Because this saves the old value of A, which we need for this expression, and uses that instead. Okay? So now let's run our code and see if it works. And, of course, all of our tests pass.